Okay, here comes part 2 of the video collection for today. Sorry I can't be there again. But let's go and take a look at page 2 of the review packet. Since I can't answer any questions directly, I'll go ahead and just do maybe a problem or two from each section, and then we'll get you guys started on your activity as soon as we're done. So, first one. Pretty simple. We have an area product and sum model for multiplying our pieces together. It's almost like a Punnett square from biology. So if we were to look at the pieces here, we've got an x here and an x here. The area of this model here is going to be 2x squared. Right, and I just got that by multiplying the x and the 2x. To get this piece here, what I'd do is I'd take the 2x and the negative 3 and I'd multiply them, and I would get negative 6x. Right, again, I'm just finding the area of each piece right here. So to get the area of this section would be base times height, right? Just like the area of a rectangle. 1 times x would get me x. And then likewise here, negative 3 rather, times 1 would be negative 3. So it looks like we're being asked to do two things. We have area. Whoops, I think I'm going to change colors on that. That way it's more visible. We have the area as a product, and then the area as a sum. Now, remember, product is the result of two things being multiplied together. This is always going to be your base times height version of this problem here. So what's the base? Well, the base is 2x plus 1, right? So that's going to be 2x plus 1. Now, what am I going to multiply that by? I'm going to multiply that by an x plus negative 3, or simply put, x minus 3. And there you go. That's your area as a product. And it's a product because I've got two pieces being multiplied together. People on the quiz missed this still. They kind of flip-flopped them. Make sure you're being clear as to which piece goes where. The area as a sum, however, takes all of the inner areas and adds them together. So what does that look like? That looks like 2x squared minus 6x plus x minus 3. Again, what did I do? I just took all the pieces and I summed them all together. And from here, so that we can get full credit, I'm going to go ahead and combine some like terms here. I get 2x squared minus 5x minus 3. And those should be the two answers for part 6C. The other problems kind of follow the same pattern. There are just certain other things missing, but we'll move on to the next section. Of the numbers in number 7, actually this is not 7b, what am I thinking? This is 7a. This is 7a, I apologize. But 7a is the most complicated looking out of all of them. 7b is a little complicated as long as you can separate all the shapes, and that kind of is how you would tackle a shape like this. Just kind of handle the individual shapes on their own. If you notice how these guys split each other down, there's a 90-degree angle here, which means that it stands to reason that there should be a 90-degree angle here, a 90-degree angle here, and a 90-degree angle here, because we're making straight lines across the shape. So make sure we're paying attention to that. Well, in order to get these lengths, these diagonal lengths, it's going to require a lot of Pythagorean theoreming. Okay? So from here, if you know that this is a 3 and this is a 3, that makes this a 45, 45, 90 right triangle. So if you're fast, you can know that this is 3 rad 2. Okay? But how would you prove that? Well, what you do is you do a little bit of side work here and say 3 squared plus 3 squared is equal to c squared. You would get 9 plus 9 equals c squared. 18 equals c squared. And this can break up into a 9 times 2 equals c squared. I'm going to square root both sides. So those guys are going to cancel each other out. I get c equals the square root of 9 times the square root of 2 is the same thing as the square roots individually. So I end up with 3 rad 2 all the same. Okay, so far so good. Now again, I want to go back and actually say why I even calculated that side to begin with. It's because it tells me to calculate the perimeter of the figure. So at some point it's going to be this diagonal plus this diagonal plus this diagonal plus this non-diagonal plus this diagonal. The next thing you want to keep in mind is that this side here is also a very easy side to figure out, because you see this is a 3 and this is a 4. If you just simply put 5, and then show me that you know something, because at this level I want to make sure you guys really are being held accountable to your work. If you just put 3-4-5 next to it, I'll know what you mean. Alright, 3-4-5, maybe 3-4-5 right triangle. Okay? But if you wanted to prove it, I understand. So you could go 3 squared plus 4 squared equals c squared again, right? So what you'd get is you get 9 plus 16 is equal to c squared. 25 is equal to c squared. Hey, what do you know? C equals 5. And then that 5 goes here. So from here, how do we figure out this side? What color can I get? I can get red. So from here, there is no special relationship here between this 3 and this 5. Some people are going to see this 3, 4, 5, and they're going to say, hey, cool, that's a 4. That is absolutely wrong. There is no 3, 4, 5 right triangle relationship. That way, the hypotenuse has to be the 5. It's not interchangeable with any of the legs. So with this top right side here, we have no choice. We actually just have to hammer this one out. So 3 squared plus 5 squared is equal to c squared. So I got 9 plus 25 is equal to c squared. C squared is equal to whatever 25 plus 9 is. I believe it's 34. So if you square root both sides, you get c equals rad 34. And that is what goes right here. Now the last piece is going to be the most complicated, because what you've got here is you've got this side that shoots up like this. Now what it's telling you is it's telling you this whole dotted line is 5, but this small piece here is 2. So actually, that makes this 3 long, because the 3 plus the 2 will get me the 5. The height of this red line is still 4, like its counterpart over here. So based on what we have on the right side, we can replicate it on, the other right side, which is the left side. We can duplicate that onto the actual right side and call just the hypotenuse 5. Again, how do we know that? 3, 4, 5, right triangle. Hopefully we're doing okay so far. Now, why did I do all this? It's because at the very end of the day, I'm going to sum up all this mumbo-jumbo on the outside to get the perimeter. So to find the perimeter, it's going to be 3 rad 2 plus rad 34. I'm just going in clockwise direction, starting from 3 rad 2 plus 5 plus 2 plus 5. Not a lot of simplification that can go on here, but these guys can all combine out to become 12 plus 3 rad 2 plus rad 34. And that is our perimeter. And now from here, to find the area, all we have to do is we just have to add up a bunch of shapes of the area. So let's go ahead and do that. So I'll go ahead and keep it in the same color code here. So this left triangle here, I'll keep it in this magenta color. So the area is going to be equal to 1/2. Remember, the area of a triangle is 1/2 base times height. There are 1, 2, 3, 4 triangles here. So I'm going to be doing 1/2 base times height 4 times. And then I'm going to add a base times height for this rectangle 1 time. So again, 4 rectangles means 4 1/2 base times height formulas. Okay, so here comes the first one. So 1/2 3 times 3. Where did I get those from? Remember, it's 1/2 base times height. In fact, I'm going to write this down. The area of a triangle is equal to 1/2 base times height. That's where the 2 3's came from. Okay. Plus this right triangle right here, the right side triangle, which I did in red. 1/2 base is 5, 3 is the height. Now I'm going to do this green triangle here, right? This green triangle, I'll do 1/2 base, which is 3, times height, which is 4. Now, for those of you who are faster, you would recognize that there's another one here, so this 1/2 I can actually just make go away. But for those of us who can't see that, it's okay. I'm going to do it a little bit slower. So again, what have I done so far? I've done the magenta's area, I've done the red area, and I've done the green area. Now it's time to go to the rectangle. Now, up to this point, we've done quite a bit of 1/2 base times height. it's easy to get into a rhythm and accidentally do 1/2 base times height for this rectangle, which I'm going to do in sky blue here. But remember, it's a rectangle, so it's really just plus 4 times 2. Again, why? Because this is a rectangle. Please don't get into the habit of just doing 1/2 base times height for everything. That doesn't apply to all shapes. So again, the last 1/2 base times height will come from this left underside triangle here, 3 times 2. And now we have to add some stuff up. So how do we do that? This is going to become 9 over 2 plus 15 over 2 plus, these guys can cancel, leaving me with a 2 here. That gives me 6 plus 8 plus, those guys can cancel, thank goodness, for a 3. 15 and 9 are going to combine out to become, I believe, 24 over 2, which becomes 12 plus 6 plus 8 plus 3. So 12 plus 14 is going to get me 26, plus 3 gets me 29. And that, I believe, is your final area. If you need to, go back, take a look at this problem again, hit the pause button if you need to copy this down. I'm going to move on to Section 9, actually, because Section 8 is just a bunch of rewriting converse statements, which I think you guys are pretty good at. So I'll do a couple of flowchart proofs, and then we'll be done. Alright, here we go. This is 9A. So, pretty straightforward enough problem. They give you everything that you need. All of our justifications will be given. Please bear in mind that when you do a proof, when doing a proof, it's just like the movie Sherlock Holmes. You have to know where the problem is going in order to be able to prove it. So we should already know that our weapon of choice is going to be angle, side, angle. Okay? And again, why do I see that? It's because I see two angles with a side squeezed in between, and that's really all I need. Yeah? So from here, how do I prove that? Well, unfortunately, these triangles are kind of flipped, but I can say that angle A is congruent to angle D, right? Because I've got this hash mark, I've got this hash mark. I'll go and put that in my little box. I'll go and call this given. My sides, right? AB is congruent to, looks like DE. Again, keep the letters in order, right? That's my side, right? Again, what did I do? This is my angle, this is my side, and I know this is going to go angle, side, angle. I'm just trying to make it go the way I want it to go. Again, that's given, right? How do I know it's given? Because they tick marked it for me. And then the last one is going to be angle B is congruent to angle E, and that's my final angle. This is also given. Pretty simple kind of proof problem. We're just getting warmed up right now. That means that triangle ABC is congruent to triangle. Now keep the triangles in order. I went from single to double to nothing. So single to double to nothing, DEF. It happened to be in alphabetical order, but it doesn't always have to be that way. And we know that from ASA, either the congruent symbol, you can write Kong, it's up to you, but that's the first one. Pretty simple. We'll move on to a more complicated one right now. Okay, this is 9E. Now, it's not much more complicated than the other one. I do want to save the more complicated ones for you guys to do. I'll be back on Wednesday, and then at that point, I do want to welcome some questions, because these flowchart proofs are definitely important to know. They will very likely be showing up on your unit test, so we want to make sure we lock them down. So I'll do this probably more like a easy medium-ish size of a problem, and that's just because they didn't give us everything we needed. So from here, you've got to know. Remember, you have to know what you're looking at here. We're looking at side, side. It's not going to be side, side, angle, because that's basically angle, side, side, and we know that angle, side, side does not prove congruence. So if we have two sides with no angle in between, it's got to be side, side, side if there's going to be any congruency at all. Luckily, it is side, side, side. For those of you who saw this happening, good for you. We'll talk about that in a second. I know that GH is congruent to what? If it's GH, then it's going to be IJ. And how do I know that? Well, they gave it to me. from here, HI is congruent to JG. How do I know that? They gave it to me. And now the last one is GI is congruent to IG, and that's where our good old friend reflexive makes his triumphant return. So what did we identify here? A side, and a side. So based on that, all we need is now that triangle GHI is congruent to triangle IJG. And what would be the theorem that allows us to say that? That would be SSS Kong, and then we're all good. Okay, I think that does it for the final exam review video, or not final exam, unit test review. And then we will take questions on this again when I come back. Get started with the activity.